All right, in section 6, we're going to start looking at some other parts of graphs, and those namely are going to be the intercepts of some different functions and then the zeros of those functions. So in general, intercepts are when the graph is going to cross an axis, generally the x or the y. So a y-intercept is where the graph is going to cross the y-axis. So if I think of some graph, the y-axis is going to be where it crosses at the y-intercept. Okay? And the most important thing about all y-intercepts occur at a point where x equals 0. Because if I think of this point on this graph, it's the point 0, comma something. 0, comma d, we'll say. And then the x-intercept is going to be the points where it crosses the x-axis. So in this little example, there's one here, and one here, and one here. And those are going to be all where the points where y equals 0. Because these are points like c, comma 0, c, comma 0, and then any other point on that, a, comma 0, whatever it be. So the y-intercepts are always going to be 0, comma something. And the x-intercepts are going to be x, comma 0. Some kind of x value. Now another term you'll hear a lot is what's called a zero of a function. So a zero of a function is going to be the number r such that f of r equals 0. So it's a number I plug in and I get 0. For example, if I have f of x equal x plus 3, a very simple one, then the 0 is simply going to be negative 3, because negative 3 plus 3 is 0. Now, interestingly enough, there is an association between the 0 and the x-intercept. So the zeros always occur at the points of the x-intercept. So really, if you want to find a 0, we're just finding the x-intercepts, or all the points where y equals 0. So we'll look at some examples of using the graph and then using a little bit of algebra to find some of these intercepts. So if we look at this first example, it says, use the graph below, name all the x and y intercepts. This looks like some kind of cubic curve. So the important points I'd want to point out is I have this point here, I have this point here, and this point here. So those would be kind of the points where it's touching or crossing an axis. So as far as y-intercept, I think the only y-intercept would of course be 0, negative 4. And there are two x-intercepts. So the first x-intercept is going to be at negative 2, 0. So x value and then the y value 0 like we thought. And then we have this interesting one over here at 4, where the graph appears to touch it and then just kind of turn around on it. That is still considered an x-intercept though, because the graph is touching the axis at that point 4, 0. And again, you can notice both of these have a y equals 0, and all x-intercepts have y equals 0s. Now, interestingly enough, using this same knowledge, we can also say this polynomial or this function has zeros at x equal negative 2 and 4. Because remember, the x-intercepts are also showing where our zeros of our function are. So if we look at this next one, we have this kind of periodic function. So this appears to start at negative 3 and then goes down and up, and then it crosses here again, 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 and stops there. So if we talk about y-intercept, the y-intercept is actually relatively simple. There's just one, and generally speaking, there's only one y-intercept for functions. And there's a y-intercept at 0, 0. Now x-intercepts, there's lots of them. There's lots of x-intercepts in there, so we can just start listing them out. So it's really everywhere where it touches that x-axis. So we're talking negative 3, 0. We're talking negative 2, 0. We're talking negative 1, 0. 0, 0 is both a y and an x-intercept in here. 1, 0, 2, 0, and 3, 0. So these are all x-intercepts. So there's quite a few. There actually could be more. If this graph continued this pattern, you could actually almost envision there being infinitely many x-intercepts. So the zeros of this graph are going to be x equal -3, -2, -1, 0, 1, 2, and 3. So the graph of the function is really nice, and if you have the graph, pretty easy to pick out intercepts. But a lot of times it's actually a better idea to do a little algebraic check of what our zeros are and then verify it with the graph. So we'll do some algebraic checks to find the x and y intercepts, and then we'll check our answers with the graph of the function. So just remember, if you recall from what we said, all y-intercepts are where x is going to be equal to 0, and all x-intercepts are going to be where y equals 0. So armed with this knowledge, we can actually figure out what these zeros are. Okay? So this first one, we have a pretty simple one. It is x squared minus 7x minus 8. So if I want to find the y-intercept, all I have to do is plug in x of 0. So that's going to be f of 0. So that's going to be 0 squared minus 7 times 0 minus 8. So that's going to be -8. So right away I know the y-intercept is 0, -8. Now as far as x-intercepts are typically a little more difficult. So x-intercept, we said y is going to equal 0. But I don't really see a y in this function. I see f of x, I see x. But remember, f of x is the same thing as y. So I'm just going to replace the whole f of x with 0. So I'm going to solve the equation 0 equals x squared minus 7x minus 8. And so now this one is a quadratic, so we can solve this a ton of different ways. The easiest way, I think, is just to factor, because we're looking for two numbers that multiply to -8 that add to -7. That's just x minus 8, x plus 1. And so if I set those both equal to 0, x minus 8 equal to 0, x plus 1 equal to 0, x will equal 8, and x will equal -1. So our intercepts would be 8, 0, and -1, 0. So with a little bit of algebra, I found the y-intercept, and I found both x-intercepts. And then, of course, the zeros would just be 8 and -1. So I'll leave it to you to graph this function in Desmos and just verify that these actually are the intercepts. All right, let's look at g of x here to the right. We have x cubed minus 6x. So same idea. For y-intercept, I'm just going to set x equal to 0. So that's going to be g of 0. So that's going to be 0 cubed minus 6 times 0. So 0 cubed minus 6 times 0 is just 0. So the y-intercept is 0, 0. So this thing should cross the origin at the y-intercept. And so again, when we do our x-intercept, we should kind of figure there's going to be 0 too, because the origin is on the x and y axis. So again, x-intercept is when y equals 0. So we're going to have 0 equals x cubed minus 6x. Now this one's going to be a little trickier because we're not going to be able to factor this one all the way. I do see that I can take an x out and have x squared minus 6. So now I have two factors, and I really can't factor -6 because that really isn't a perfect square, so I can't really utilize my difference of squares. So what I'm going to do is I'm just going to take both of those factors and set them equal to 0. So I have x equal to 0 and x squared minus 6 equal to 0. So this one is pretty much done. 0 equals 0, and that's again going to be our same intercept from above. 0, 0 is an x-intercept. Now the second factor, a little trickier. What I'll do though is I'll add 6 to both sides, so I'll get x squared equals 6. And then if you remember from algebra, I can take the square root of both sides, but when I do, remember I'm going to add a plus or minus. So I actually have two numbers, plus or minus square root of 6. So the two other x-intercepts I'm going to have are radical 6, or square root of 6, comma 0, negative square root of 6, comma 0, and then, of course, the 0, 0. Now, if you check this on Desmos, you can certainly see 0, 0. You will not see the square root of 6 and the negative square root of 6. Instead, you'll actually see their decimal equivalent. Desmos does not give you the exact root number. It just gives you the decimal approximation. So you should look at that and see what it has. But these are like 2.45-ish, comma 0. Now, we'd obviously want you to list the exact value, but if you're looking on Desmos, they should cross at about these two numbers. All right, so once you've checked that, we can go ahead and look at the last two. Now, this one looks a little longer, but actually it's really, really nice because it already has everything factored out. So y-intercept, we're going to still do the same thing. We're going to set x equal to 0. So h of 0 is going to be 0 minus 7 squared times 0 minus 3 times 0 minus 1, which is going to be negative 7 squared times negative 3 times negative 1. So that's 49 times 3, which is 147. So our y-intercept is 0, 147. So this would be really, really, really high up on the graph. So this thing would go pretty high. Now, x-intercepts are actually going to be really simple for this one because it's already factored. The x-intercepts are when y equals 0. So again, if I want y equals 0, 0 equals x minus 7 squared, x minus 3, x minus 1. Since it's already factored, I could just take each one of these factors and set it equal to 0. So x minus 7 equal to 0, which is going to give me x of 7. X minus 3 equals 0, which is going to give me an x of 3. And an x minus 1 equals 0, which is going to give me an x of 1. So my intercepts are going to be 7, 0. It's going to be 3, 0, and 1, 0. So lots of intercepts for that one. 3 x-intercepts, 3 zeros. 1 y-intercept. Remember, y-intercept does not include the zeros, only the x ones. Okay, let's look at one more example. This is a third-degree polynomial, but the same process will apply. So for the y-intercept, we're going to set x equal to 0. So that's going to be f of 0, which is going to be 0 cubed minus 0 squared plus 10 times 0 minus 10. So everything's going to cancel out except for the negative 10, so that equals negative 10. So this has a y-intercept of 0, negative 10. X-intercept, same process. X-intercept, we're going to look where y equals 0. So it's going to be 0 equal x cubed minus x squared plus 10x minus 10. So this would be a pretty difficult one, but we can still factor this one. This one we factor by grouping. So we take these first two and these last two terms away. So whenever you have 4 terms, this is a really easy way to factor. So I'll take x squared out of the first two, and I'm left with x minus 1. And out of the last two, you see I have a 10 in both, so I can take a 10 out and have x minus 1. And now I have this same factor in both of these, so I can take that out. So that's going to be x minus 1 and x squared plus 10 equals 0. So if I set these equal, x minus 1 equals 0, x will equal 1. Now for this one, x squared plus 10 equals 0. If I try to solve that, subtracting 10 will give me x squared equal negative 10. But if I take the square root, that is not going to be real. So that's not going to be an intercept. So we only have one x-intercept, and that's 1, 0. So go ahead and graph this function and verify there's one y-intercept at 0, negative 10, and one x-intercept at 1, 0. So a little bit about intercepts. Please let me know if you have any questions.